Hey, welcome back, 7th grade. We're going to be pushing into problem 3.1, a whole new investigation that's going to be based on looking at solving equations in a whole new light. So we definitely want to make sure we remember everything we learned about graphing, making tables, and how that plays into the equation. So all that stuff's going to be built on for this next investigation. I know some of you made it to the Google Meet that we had on Tuesday, March 31st. And we actually went through some of the notes already, but for those who didn't make it, I want to make sure that we have an opportunity for you to see that work the same way. So with that, let's go ahead and jump in. So before we get going too far in, we have this new investigation. It's going to be all about solving the equation. Actually, today's notes are going to be about this equation here for Alana. If you remember, she had that $5 initial value given for her walkathon plus the 50 cents for every kilometer. So we're going to work with this equation. We want to make sure we understand that the solutions for those are based on showing up in a graph. For example, if they said that she walked 3 kilometers, you see that she could get $6.50 for that. Or if she walked 30 kilometers, she could get $20. That's what those points are going to be referring to. So when we solve for equations, we're actually going to be getting one answer, but based on another one being given. So they're going to give us the distance, we're going to find the amount earned. Or if they give us the amount earned, we're going to find the distance. Same idea, we're going to be using the table. Be looking for those patterns. Remember how we talked about it's going to be like as this goes up by 1, this goes up by 50 cents. We want to be able to see that. And the same thing, we kind of use the counts as well for larger ones. So with that, let's go ahead and start with today's stuff. So the idea is we're going back to that same equation for Alana. Her amount of money is going to be based on the $5 initial amount plus 50 cents per each kilometer. And if we knew what the amount of money she earned was 10, we'd actually would plug that 10 in for A, and it would look like this. 10 equals 5 plus 0.5 times D, and we substitute that value in for A. So with that, we actually would go through and figure out like, well, $10. She gets $5 to start, so then how much minus, so if I have 10, take away that 5, what distance would she have to need to go to get half of that plus 5 equals 10. So we kind of asked ourselves some of those questions. So for today in part A, we do that exact same equation, but they're going to be asking us to plug in the value for 23 kilometers and figure out, well, how can we show that first of all with a table and with a graph. So let's look for 23 kilometers in the table. If I come back to the previous page, we would actually work through here and see that 23 would be right here between 20 and 25. So you can see right here that if I had 15, so 21 would have to be $15.50, 22 would be $16, and 23 would be $16.50, because you see that continued 50 cents for every one of those. To see that for a graph, look here specifically, we go across to where you see we're looking to get, okay, so 23 kilometers, 23 kilometers down here, it's right in this area for 20, go straight up. You see it's going to be kind of above 15 a little bit. Hard to see exact in both of these. So the table we could find it out for sure. The graph's not as exact, but that's what we would do. We would go across the graph here to that place and go up to meet the line and then back over to the y-axis to see the amount of money earned. So then part B says, write an equation that represents the amount of money Alana collects if she walks 23 kilometers. Use the equation to find the amount. So I'm going to come here. And we already talked about A1A, so I'm going to do A1B. And our equation is A equals 5 plus 0.5 times D. And they're asking us to put in 20 kilometers. Remember, D equals 23 in this case. Oops, I'm too zoomed in. There we go, a little better. So I'm going to take this 23, I'm going to plug it in for that D. So I'm now going to have A equals 5 plus 0.5 times 23. I don't know that off the top of my head, but I'm going to actually do that multiplication first to sort that out. So if I do 23 times 0.5, 5 times 3 is 15, 5 times 2 is 10, plus 1 is 11. One swoop there. Okay, so it looks like I've got 11.5. So now I'm going to have A is going to be equal to 5 plus 11.50. And that's that 0 is going to be because it's like money, remember? So if I add 5 to that, so I come down here and put my $5. Be careful of the decimal points. So 0, 50 cents, 6, and 1. So it turns out that Alana would get, for going 23 kilometers, she would get $16.50. So I hope that part makes sense there. But can we use that equation to find the amount? Yes, we can. We can figure it by plugging the exact amount in and figuring it out exactly. So now we're on to A2. Suppose Alana writes the equation 30 equals 50 plus 0.5 times D. What question is she trying to ask here? Well, before we knew that we'd put the 23 in here because I'd be trying to find out the amount. So if there's 23 kilometers, we found out we would get $16.50 here. But in this case, if they give us 30 here, that actually means that, well, we're going to try to figure out how many kilometers does she have to walk to earn $30. And so we're going to actually do that, try to figure out how many kilometers she'd walk to get that. So show how you can answer Lana's question by reasoning with a table of values. Okay, so back over here again. If I know table of values, I needed $30. Well, I would have to continue this table quite a bit down here to figure out what it would end up being. And I could do that. I could add 10 here and do that work over here and kind of work along that way. That's what I would do. Or over here, I can actually see that if I go to find $30 over here earned, I can come to this part here, up $30 and cut across to the graph. Ooh, it looks like it hits right there. Come down to 50, do you see that? If I go up to $30 earned, straight across that line over to the graph, and then come back down to the x-axis, I would get 50. Looks like she's gonna have to walk 50 kilometers to earn that. Both of those are kind of like hard to notice because you have to look for them and see what you can find. But then they asked us to figure out, or with the equation. Now they said or in that case. I'm gonna go ahead and do all of them, but here's our situation with the or, and I'm gonna do that with the 30 equals 5 plus 0.5 times D. So here's our B, or no, this is A still, my mistake, A, 2, and B. So I'm gonna put that same equation this time, I'm gonna write it with a 30 in there. So I've got 30 is equal to 5 plus 0.5 times D. So the question that we ask ourselves is this amount, whatever it is, plus 5 has got to equal 30. Well, if I think about what number plus 5 equals 30, it's got to equal 25, right? Because I would do in my head 30 minus 5 equals that 25. So something over here has to equal 25, and we'll get to that in a minute. But the idea is, because I know I subtracted that, I would need to actually show that on paper. We're going to practice this more and more in this investigation. So I'll do minus 5 on both sides. This will cancel. 30 minus 5 is going to be 25. And that's what we knew. See, we knew this had to equal 25. So I bring this down 0.5 times D. So now some number times 0.5 equals 25. Now I think I know what it is in my head, and we saw it on the graph there we showed, but we need to go through and do that actual work. So if I don't know what number times 0.5 equals D, I would do the opposite of multiplying. I would divide both sides by 0.5. This becomes a big giant 1D, and then I'm going to be doing that 25 divided by 0.5. But because it's a decimal, I'm going to add my 0 and then extra swoop. So 5 into 25 goes 5 times. Bring down my 0. It's going to be 0 times 0. Look at that. So it's going to be D is equal to 50. Just what we saw. The distance is going to be 50 kilometers to get $30. All right, guys, moving on to part B. So now we have a new equation. So the equation D equals 25 plus 2.5 times T is related to situations that you've explored. In part 1 and 2 below, the value of one variable in the equation is known. Find the solution, or that means the unknown variable in each part. Then describe another way you can find the solution. So here we go. Number 1, D equals 25 plus 2.5 times 7. So here we go. B1, D equals 25 equals, wait, that's all right, plus, not equals, 2.5 times 7. All right, so we gotta work by word of operations. We gotta do the multiplication first. So 2.5 times 7, it's gonna be 35. 7 times 2 is 14, plus 3 is gonna be 17. 17.5, so I've got 25 plus 17.5. I'm gonna bring that down, put my 25 out here. Oops, that's a 0, sorry. I'm gonna have it be 5 points, it's gonna be a 2 and a 1, 42.5. So the D in this case would equal 42.5 in that case. Okay, that's how you would do it. So another way you could do this is we could actually make a graph. We could plot this information on there. We could make a table and put in a series of numbers to figure out if that would be the same as well too. All right, on to B2. We have here 70 is equal to 25 plus 2.5t. All right, so now this goes back to what we just got into doing. That was like part 2 on A. Something plus 25 equals 70. So the idea of some number plus 25 equals 70, I don't know that, so I would actually do some 25 taken away from 70 to figure out what that is left over. So if I do minus 25 on both sides, this is going to cancel. 70 minus 25 is going to be a 6, this is going to be a 5 and a 4. So I get 45 equals 2.5t. Same idea, I need to divide both sides by 2.5. This becomes a giant 1t. So now I'm going to have 45 divided by 2.5. I need to do that division swoop, so I'm going to add a 0 and then divide by 25. 25 into 45 is going to go one time. 0, get 200. And then 25 into 200, that's kind of tough. But if I think about quarters going to $2, I know it's going to be 8 quarters gives me that. So I'm going to have, it's going to be equal to 18. So another way I can find that out is actually if I had a graph, I could go up to 70, cut across the same way, or make a table of values, plugging in a bunch of different numbers, and do the same thing there. All right, so not too bad today, kind of quick. So let's take a look at our ACE work. You're going to be just doing 1 through 4 today, specifically related to this particular problem. All right, here we go. Mrs. Chang's class decides to use the Cool Tees company to make their t-shirts. Here's the equation. So C is the cost. Is going to be N is number of shirts. So C equals 2 times N plus 20. 25 t-shirts. Describe how you can use a table and a graph to find that. Suppose the class has $80 to buy a shirt. So describe how you can use a table or graph to find that. Then Taylor writes the following equation in her notebook. What's she asking about? What she wants to do? And Kesha puts in 30, 80. What's she trying to figure out in that case? Number 2, use the following equations to find some information about the 3 walkathon plans. You got plan 1, plan 2, plan 3. So in each of these plans, what's she trying to find out? Describe how you could find it. Number 3, find the solution for the value of the variable by solving like we did in today's work. And then lastly here, consider this equation. Find y if x equals 1. Find x if y equals 50. Describe how you can use a table or a graph. All right, guys. Hopefully that was pretty straightforward. Again, if you missed our Google Meet today, we had on March 31st. We did a lot of explaining here. But hopefully you can meet us in the future if you have any questions. All right? If you have any questions too, you can message me, Remind app, Google Classroom, email. Any of those options will work too. All right, hope you're doing well. Hang in there, guys. Hope to see you soon. Later.